Alright, time for another draftphysics.com, debatephysics.com also, but not too many people wish to debate physics. Yeah, they want to debate something else, but they don't want to debate physics, ideas, or concepts. So anyway, this edition will be on the subject of the distinction between energy, okay, which is little stuff moving really, really fast, the speed of light. So you could just put a C after it. Because all the real energy is just stuff moving the speed of light. And matter, which is all just dead bits. So you could see the whole universe as clumps of matter, electrons and protons, and little stuff, okay, that never stops, and it's all moving the speed of light. So all the matter only moves when something moving the speed of light is possessed by it, essentially pushing it. So you can think of the electron and proton as something that can collect bits of energy moving the speed of light in a direction. Now it can't collect bits in two opposite directions, so in a sense it has to have some kind of gyroscopic kind of element to it where it can only have bits, okay, in the three dimensions. It can only have three orientations of motion, but it can have all three. So theoretically, something could move in all three dimensions. A piece of matter could be moving forward and back. It could be moving forward at the speed of light, and it could be moving up at the speed of light, and it could also be moving, the other one would be left or right at the speed of light, theoretically. Now, the reason why matter can't go the speed of light is because the force is what's pushing it, and it's going the speed of light, and when it's pushing matter, it's work, and so it slows down. So maybe it's 10%, maybe it's 1%, who knows, of the speed of light. But when a bit of force does interact and stick to a piece of matter, it does move it slower. So a force bit that would end up over here, it doesn't get there. It takes time. And that time, that reduction in its motion, its progression through space, is essentially what's causing the lack of equilibrium between the amount of force coming down on you and the amount of force the Earth is pushing back with. And that differential in this field of little bits is what gravity is. It's not just a bent geodesic. And the arguments for this are so numerous in the sense that you can understand that gravity behaves just like light in reverse. So it's essentially, the universe is very bright and the Earth is very unbright, okay, less bright, and you're basically just being pushed in a field of photons. And the same analogy works. The sun produces light at the inverse square law. The same rules apply to the light. This hand, gets 4 times bigger when I go half the distance. Same rules, because it's photons and because they're all leaving my hand in all directions and spreading in 2 dimensions. They're moving this way and they're spreading this way, and that's the square. If they only spread in 1 dimension, then there wouldn't be an r squared. There wouldn't be an r, there would just be an r rule. And there's an r squared because it's separating. They're traveling away from each other in 2 dimensions. You can only see the 1 dimension, okay, in a drawing, but it's 2 dimensions. It's making a square, okay. That's why it reduces so dramatically. It's because it's spreading 2 ways. Alright, so I think we could use with an erase and continue. Alright, well, back to the understanding it as a closed system. You could understand that if I did have little bits that were perfectly elastic, let's say, except when they hit matter, and even if we did say they exchanged their energy or stopped moving when they hit the matter, you can sort of understand that if I had two solid objects in there, that they would shield each other essentially from some of the force. Some of the force couldn't get to this one because it would be blocked by the existence of this one. Every bit of force going this way would hit this one, and there wouldn't be any force hitting from this direction, and so there would be more little bits hitting from the other side, and they would coalesce. They would mock gravity. All right, it would appear like they were being attracted to each other by charge or gravity. And that's basically how the system does in fact work, is that the universe is full of energy, and you're just looking to create differentials by relationship to each other. Things have a relationship to each other, and through that they disturb each other's environment, and now what hits them is different, and that's why they behave at a distance, is because they can essentially see the other guy before he gets there, just like you can see something a mile away, and you can watch it get closer and closer. It's because it's, the universe is showing it to you, and some of that we can see with photons, and some of it is happening whether we can see it or not. Example might be free falling in gravity. As you're falling, the air is resisting, and what you're basically doing is you're getting the force from the gravity, and then you're exchanging it with the atmosphere. The atoms below you are being pushed by you, so you're sacrificing your speed. You would be going faster if you weren't giving your energy, throwing little bits, pressure onto these atoms and forcing them to go with you. And the fact is when something does fall, the atmosphere that you've pushed actually hits the ground first. It actually can be weighed. You can take a scale and you can actually weigh something before it actually lands, because the pressure will be almost the same as your weight, in terms of if you've reached a terminal velocity, you've now compressed as much as you can compress, and it equals your own weight. That's why it equalizes, is because the pressure you're creating is as high as the pressure that's pushing you. So anyway, it's just another piece of evidence that gravity's a real thing, not a fake thing, not a bent geodesic, not a nothing. It's a something. And so that's really the important distinction, though, is the idea of hitting something, having an object hit, and then the little object stops and the other object goes. That's not what's happening. For the real universe, the tiny one, the electrons and protons, the force is actually just occupied by pushing. The pushing is always real, so it's always an active force. There's no potential involved. There's either you have it or you don't have it. You've either been changed or you haven't, and there's no taking in any other sense than combining. So the energy can really be thought of as the primitives used to think, that energy was a fluid, and it was a fluid. Electricity was a fluid. All this stuff was a fluid. And I don't know if they took that seriously. I think they just thought of it as behaving as if. And so the fact is that what happens when things exchange, like say in a Newton's cradle, and you have energy in and you have energy out, it's just basically an exchange. The stuff that was in this, the orientation in a direction, the pushing, the bias. The little electrons had a bias. They were a certain distance from each other, had a certain amount of pressure, and what they did was expand, and they contracted in this. They got the pressure, and the pressure is basically going to decide orientation. So it's a little, that this is the slight complication, is the truth is that you can't, because there is force everywhere in the universe. I mean, it's going everywhere in all directions. If an electron, for example, is given a piece of energy, something sticks to it, and motivates it to move in a direction, the fact is it's going to move into more force in the direction it's going than in the direction it's running away from. So even if it's only 1/10 of the speed of light, it's still going faster. And that means the photons that are behind it, heading for it, can't catch up to it as fast. They're retarded in their capacity to push it because it's moving the same direction they're going. And so there's a differential, and you'd think a reversal will take place, and that's what actually does happen. Electrons and protons can't be shot any distance, even in empty space. You can't make a gun and shoot electrons to the moon or to another satellite. We can't communicate in space throwing electrons at something because they won't make it. They won't survive the trip because they are, in fact, dragged to a halt by the existence of the force. And so the complication is that inside of nucleuses you have a scenario where you have protons and electrons. And the fact is they call this the strong force. So it's like one of the strongest forces in physics is the idea of two protons. And the fact that in the nucleus they're very close to each other. And that should be impossible because of their hatred, the fact that they reflect energy, okay, back and forth. They don't accept energy from somebody else and they throw it back and forth, and you can understand the closer they get to each other, the more energy they're reflecting. So they're mirrors to a force. That force reflects between them, and so this is understood to be like I said, the strong force. And there's no special force that creates the opportunity for protons to be next to each other. The special circumstances is that electrons have the opposite effect. So if you put an electron between two protons, then it's perfectly understandable how they could get very close to each other, because the electrons are only repelled by electrons and they're attracted to protons. So two protons can have an electron between them and they could be very comfortable being very close to each other. So it's actually not a strong force, it's an incredibly weak force. It's the absence of force that makes it possible for protons to get very close to each other. So you can have either configuration. You have electron, proton, electron, or proton, electron, proton. And this mechanism can travel through space, because it could be understood that there are two kinds of force. I mean, there's a proton force and an electron force. So all the little energy bits does come in the same two flavors that the matter comes in, electron and proton, plus, minus, north, south. And the fact is that all of the pressure that the proton, if this thing was moving in this direction, all of the pressure couldn't get to this object in the back. So if we give it, okay, momentum, we give it force pushing it, it could be understood that all it can do is push on the electron. It has to get so close to the electron that it actually physically pushes the electron, because none of this drag force can get to this one in the back. It can only drag this one, okay, in the front, and cause it to get closer to the electron, but it can't really get to this one in terms of it can't get there as a force. And so this one's like a little motor. It just keeps pushing. And so when this one stops, this one re-injects motion in the forward direction, because it keeps its energy, more likely to. And so what you're really doing when two things combine is what you're probably doing is just orienting some of those pieces that are already moving in directions, that already have an orientation in a direction, and you're just lining them up. You're just saying more of them are in alignment now. Okay, when you add energy, you're just changing the direction of these little bits that tend to keep motion. And the more of those you line up, the more you tend to go in that direction. So that's what's really happening when they exchange the force. They're really just changing the orientation of these little mechanisms inside the nucleuses of atoms that do have a perpetual direction. They're always going to move in the direction of their alignment. They're not going to move in some other direction. They're only going to move that way or that way. Okay. once you've made one, that's it can only go faster this way or faster that way. It can't go some other way because the balance consumes any other direction. Alright, so I'll try some key points is that the energy, it's all moving the speed of light, which means it's the speed of force, okay? And so it's not speed of light. Alright, it's everything that's invisible, the invisible quantity that's being exchanged. All of it moves at the same speed. So gravity, the physicist will admit that if the sun disappeared, it would take 8 minutes for the Earth to know that the sun was gone, that the energy, the geodesic, the bent space, whatever you want to call it, does in fact take the same time as the light to get to us. So when we see the sun disappear is when we will feel the sun disappear. So it's all the same. Gravity, electricity, magnetism, they all have a maximum speed of the speed of light. And so we should be saying the speed of the elemental force. So all of the force is moving the same speed. Alright, the other thing to be clear about is that things like magnets and electrical wires or other things, they're, a wire with electricity going through it. All these things are in the universe, and again, they see each other, okay? They create a change in what comes in, okay, and what comes out. So magnets are not generating, they're not radioactively decaying. They're not doing something internally to produce energy or to produce an effect. All they're doing is changing their surface. Their surface changes. Well, you could say their composition changes. All the bits inside of them line up, and so when a force hits them, okay, it does go just like gravity. A lot of the force goes right through them. But whatever goes through them changes. Every time it hits a piece of matter, it gets changed. And those changes are what's changing how it looks. So there's stuff going through that gets changed, and then there's stuff that just reflects off the surface and that gets changed. So you can understand that all that's really happening is that it's excreting an image, and the image changes when the material changes. So if you take a piece of iron and you line up all of its atoms, plus and minus, in terms of their bias, okay, their shape. Let's say the atoms had a shape, and you just make sure all the atoms, the shapes are all pointing in the same direction, okay? Then when something goes through that, it will produce the same effect. It magnifies the effect. So the more little bits you can change to be all aligned, the more effect you have. So the stronger the magnet. And the same thing with the wire. The more electricity you can put through, that is the more amperage, which means the more atoms are going to be affected. So amperage is the number of atoms conveying the potential, and pressure is how much each electron is pushing with, how much pressure, how much velocity it has, essentially. So the voltage is the velocity, and the amperage is the volume. You can think of it that way. The number of atoms. And so the more atoms you affect with the electricity, that's why you use traditionally low voltages to create magnetism in wires, because it forces more atoms to be involved in the process. That is, you're polarizing more atoms. The more atoms you polarize, the more you change how energy goes through the wire. Not the energy in the wire, but how the external universe goes through the wire and how it reflects off the wire. So you're basically changing something that's not a mirror into a mirror, you could argue, or something like that. You're not really changing how much force comes out, you're just changing how it looks. And that sort of gets to the photon argument. Alright, so photons are the things we have the most interaction with, and the simple truth is it's nothing like what they draw. So it's not doing any of this. There's not two fields, and it's not, doing this and all of that. That's a poor representation of the photon. And as Einstein kind of demonstrated, and a few experiments demonstrate, photons have a quantizable element to them. And the fact is they hit rather large surfaces. Yes, they're small for us, but it's not that pinpoint. You don't hit a single atom and a single atom pops a photon out. A photon is basically the pieces of what's pushing electrons. Okay, it's these little force bits moving the speed of light, but it's certainly more than one of them, and they're basically on a parallel path, and they have two features. They have their period, their frequency. They call it a wavelength, okay, but there's no wave involved. It's just a period. It's just an amount of time between incidents that will hit a surface. So the surface is going to be hit sequentially. You could sort of, it's sort of like in the Army, when you have an airplane and you fly in with your bullets and you scrape the surface, the bullets hit here, then here, here, here. Same kind of idea. The photon's going to cause an effect on the surface, or it's going to hit not the surface, but the atoms near the surface, and it's going to hit that surface, and it's going to cause atoms to change because it's going to give their electrons a little piece of energy. So essentially it's going to do that same thing as the magnet. It's going to take the orientation. It's going to take the orientation of an atom, and it's going to change its orientation. It's going to make a fat one thin or a thin one fat. And so anyway, but the period, and then it has the thing called polarization, which is another element of its character. It's got a shape, so it's flying through space, and it's, this pen sort of in a direction. You could say there's one dot there, one dot there, one dot there, one dot there. It's coming in at an angle. And you can change where the orientation, which way it'll go across the surface, whether it'll hit the surface going this way, or hit the surface going this way, or hit the surface going this way. And that's the polarization, and that's the frequency of the light. Even for high frequency light like blue light, it's still 500 atoms worth at least. Okay, so you're talking about a polarization that's usually proportional to the frequency. That is, this distance here is usually proportional to the distance here. And the fact is that it can be found through filters. And so you're talking about something that has to hit more than one atom, because this distance is more than one atom, 500 atoms. And so what basically is happening is energy is hitting one electron, one atom. Let's just say the energy is hitting one atom, and it's changing it, it's disturbing it. And that disturbance goes to the other atom. So in a sense, it adds energy to the neighbor, and it adds energy to this neighbor, and energy to this neighbor. And then what happens is then the second one comes in, hits an electron in this excited, half excited atom, let's say, 1/4 excited, and it gives it more energy, but now it's even more energy because it's already going. So now these atoms are going to be more excited, okay, the ones that circle this one. And then when the third one hits this atom, it's already got half the energy. You're going to add another full quantity, so now you have 1.5, and eventually you're going to give it enough energy to push electrons now. So you're basically just creating electricity. And that's how your eye sees light, is by creating electricity. That's how surfaces like metals create or sense light, detect light, is by creating electricity, causing electrons to be pushed out of their atoms, ionizing the surface, essentially ionizing an atom in the surface, and forcing a free electron to move and try to find a place to go. And it will go where there's less pressure eventually. It's trying to find a location, and all the slots are full. So all the music, it's like musical chairs, all the chairs are full. You've broken one of the chairs essentially, at least for the time being, And that electron is now going to search for a place to go. And that's how we can detect it as electricity. So photons, you can understand, are frequency dependent, so you can tell the difference. And there's all kinds of rules about how far off they can be, probably. You know, they're either half in phase or out of phase. And so all the photon experiments of some notoriety talk about interference and fringe patterns, and there really isn't any of such thing. There's just the fact that you can have two photons that are in phase, or you can have photons pieces that are out of phase, and that's the real distinction. So when they're out of phase, you can't see them. It's not going to be a photon because they're going to hit the surface wrong. They're going to impose the energy at the wrong timing and produce some other effect. So to be able to produce the effect, they have to have exactly the same timing as the movement of the electrons, the pressure inside the surface. So that's why surfaces are sensitive to green light or blue light or red light, is because the electrons in the surface are dependent on a certain amount of energy to get a certain distance in a certain time for the next hit. So the timing of the electron inside the surface, if it moves too fast, then this will be behind it. If it moves too slow, it's going to hit in front of it. You can see that the timing has to match the electrons in the surface. So there's lots of details about how this all works, but you can understand that when they're out of phase, they're just blobs of momentum. They're not photons anymore. They're just heat. They're just energy. And they can still move something, but you can't see them. All right. Yeah, so I'll think if there's some other way to say that. All right, well, I'll just throw in a quick reference to what happens when the photons encounter another piece of matter. And the fact is that there's electrons on the surface of matter, and the protons are in the back. Okay, so that's just always true of all matter. It has more electrons on the surface than it has protons on the surface. And so basically when a photon is going to travel through an opening, what it's really going to travel through is a field of electrons that are loosely held to the surface. And so the photon has an order, and it's going to hit some of those electrons. And when it hits them, it's going to give them momentum. But they already have their own momentum. They're already jiggling in and out. You could understand that the electrons are basically going to always be moving towards the protons or away from the protons. That's the motivating factor, is there's other electrons in here that are repelling them. The protons are attracting them, and they're caught in a tension, okay? And the energy of the universe is hitting them, and so they're bobbing up and down. And so the light, okay, when it goes through the slit, the little pieces of the photon, okay, some pieces are going to hit some of those electrons. When they hit an electron, when the piece of force, all right, hits the electron, and the electron already has momentum up and down, you can sort of understand that now the momentum is going to be this way and this way, or this way and this way, because it's going to tilt the electron. And then when the electron moves in that new direction, when it goes like this, it's going to basically be pushing its reflection in a direction. So you can understand that the electron's sitting here, and it's basically a reflective surface. And whatever way it moves, it's going to create more reflections in the direction it moves, and less reflections in the direction it's moving away from. So if I could move my hand near the speed of light, or at the speed of light, and I moved it forward, I would collect all the energy, because all of it would be reflecting at the same speed I'm still pushing. And so until I stopped, when I stopped, you would get all the photons, all the energy the hand collected, reflected. And the other side, there'd be nothing. My hand would be invisible from the other side. It'd be impossible to see it. So if something moves away from you at the speed of light, it's basically eliminating all possibility of reflections, and so it would become invisible. So that's what's happening, is the little bit that went in the slit straight ends up being pushed that way or that way. That's why the fringe pattern is in one dimension unless you use a circular opening. If you use a circular opening, then it fringes and makes circles. It makes a bullseye pattern. The fringe pattern is not linear anymore. But if you use linear surfaces, vertical surfaces, then all the photons will go one way, and you'll have a fringe pattern that's on that line. And it's just being created by the fact that the electrons are either moving in or they're moving out. They're moving out, they're going to push the little bit in a new direction. The new bit of force will be pushed in a new direction. And that's what's happening in the, say, the double slit, is that you'll end up with a fringe pattern because we're throwing a bunch of random bits, that you broke a bunch of photons and you threw their bits at the surface. They still have their frequency. They still have timing. And depending on the timing, they'll either be able to take this position, they'll empty this position, and they'll fill this position. So, if one's bent and is traveling a longer path, it can just fill in here and create the photon. A new one will be put in here, and it'll just recreate the photon. So you have a 50-50 chance on the surface of creating photons that are still in phase. You've just changed their position. You move this one here, and you moved another one into that position. And so you're just recreating the photon by having full wavelengths, full frequencies of a difference between their landing spots. So if one lands here, it'll be back in phase. Here, it's back in phase. Here, it's back in phase. And in these spots, it's out of phase. So the energy's still hitting here. There's still bits hitting. So if they did a heat detector or some other kind of detection, they may not see any fringe pattern because the surface is still being hit in all these places that are empty. It's just that those photons are in the wrong sequence. They're out of phase, and it can't be seen as a photon. So it's like two radio signals jamming each other. Two radio towers sending the same signal. And if it's out of phase, your receiver can't figure out which pattern is the real pattern. And so it just gives up and says nothing. Because it can't tell whether it's supposed to do this or whether it's supposed to do this. And the same thing happens on the surface, is that you don't have the right sequence of events, and without the right sequence, the right cause, you can't have the effect of the electricity. Alright, that's a little more detail than I intended for that subject. But it's sort of fundamental in the sense that light is the only thing that we have a more tangible, real experience with, of something moving the speed of light. The rest of it, magnetism, even electricity, it's certainly physical. You can certainly get electrocuted and you're going to know something's going on that's physical. And then gravity, the part about gravity is this stuff is so discrete and tiny. And the fact is it's moving your electrons. It doesn't move anything else. Gravity is a nuclear force. It's affecting electrons and protons. You aren't hit by gravity. Your electrons and your protons are hit by gravity. They're moved. And they're the elemental bits of your atom, so everything has to move the same. And if everything moves the same, you can't feel any difference. And that's the difference between something, an elevator, for example, pushing up on you. Can't see that. The elevator pushing up on you, the difference is there's not any equivalency really between the force of gravity and something pushing you. So the force of gravity in free fall is, the fact is that the gravity is pushing every little bit of you exactly the same. Every little bit's moving the same speed, so you can't feel anything. If an elevator pushes up on you, obviously you feel your legs and the lower body. You feel lots of inequality because your head isn't being moved until the signal can move through your skeleton all the way up to your head, and it's very uneven. So the pressure you feel is really uneven, where gravity clearly is a very even pressure. All right. So I think that's probably enough. I'll pause and see if I have anything else to add. So it is the speed of force. It needs to be understood. The force is the stuff moving, and matter only moves when it's collected force. And once it's collected force, it can exchange the force with other objects by contact. Alright, so I guess I'll close by just saying this is I've given you one person's understanding. And that's the way it's going to be for a while, I guess. But I think it's the Occam's razor simple answer. There aren't different kinds of energy in the universe. The universe is made out of simpler things, not more complicated things, you could argue. Photons can't do anything fancy. They're not snakes flying through space. They don't have any musculature. They can't do anything fancy. The elemental universe is really simple. It's behaving on very simple rules. It's the only universe technically is the electrons and protons. They're in the same empty space that's out there. They're in the real empty space universe where we are a collection of them. We're full of empty space still. And everything that we do, they have to do first. And they're just doing it on a time level that we can't relate to very well. Billions of interactions take place in a millisecond for us. The universe is running at a really high speed, and we're moving at an incredibly slow frame rate. But anyway, there's no fourth dimension. Time is just a function. It's just something that takes time because there's a speed of light. If there was instantaneous speed somewhere, then it would be a universe that was over that fast. But there isn't. It takes time, and it takes time for light to travel from one place to another. And as hard as it is to think of light or force, the speed of force as being slow, it's really slow. Okay, the universe is running really slow, and we're running even slower. But that's why there's time. It's not any more than that. It takes time for light to travel distance, and the fact that it takes time means everything else takes time. So the fastest thing takes a long time. That means everything else takes a long time. So there's just 3 dimensions of space, and there's just this elemental stuff moving in it, and there's no... the only reason why matter can't go the speed of light is because it has to be pushed by a force that can't go any faster than that. So that's as fast as the force can go. And you can sort of understand that if the matter is a substance, the stuff inside the matter, okay, is going to have the same limitation. It's being pushed, and the amount of force to push it would always be more than this stuff. It can only make it go a percentage faster. It can never make it go as fast as it's going, because it takes energy to push it. It takes more energy than the force has. So matter is always going to be restricted in terms of how fast it can move. And then matter, in the sense of atoms, okay, and molecules, would have even stricter rules, because not all of its bits are the moving bits. Some of the bits are tangentially attached bits, and you can't give them non-drag force. You can't. Only part of the atom can have an engine that can survive motion. The other parts won't. And so even if you tried to make matter go very, very fast, that is, matter in the form of an atom or a molecule, it would probably be sheared to pieces long before it gets even close to half the speed of light. The little bits just can't go that fast unless they're in smaller pieces. So pieces of a nucleus can move through space very fast, the speed of light almost, the speed of force, but nothing else can. The smaller bits, the individual electrons and protons can't. Only that hydrogen or helium nucleus can. Only that electron, proton, electron, or proton, electron, proton. Only that elemental thing, piece of matter, can move almost the speed of light. All right. Probably enough. All right, so anything energetic, anything that looks like it has energy, it's moving different than something else. It just means it has a different amount of the force pushing it in some direction. And yes, there are relative deceptions in the sense that everything has an absolute velocity, and the truth is this direction could be going backwards, not forwards. And so it could be absolutely going slower by going that way. Okay, because I'm going this way. Absolutely. But the truth is that the universe is a real place, and it is possible for something to exist in space that isn't moving in any direction. And then it's possible to have something that's moving in all three dimensions very fast. But there's no changing of the basic function of the universe. So I don't think I should have to go into the light clock kind of stuff. You can't, photons aren't bent by gravity. Photons are, like all the other forces, essentially indestructible. They don't interact with each other, and they only can be interpreted by a piece of matter. If they don't interact with matter, they don't do anything to change the universe. Yeah. Alright, well, we'll call it a video. So, till the next time and such, and so forth and whatnot. Again, simple answer is probably the right answer, and this is the simple solution.